Welcome to Jewish Physicist Responds. Today we are going to be speaking about naturalism and Occam's razor. So there's a couple statements that sometimes you'll hear people make in support of naturalism, and we're going to address those statements. So one statement you might hear is that the world, if we look at it and it looks like it could be natural, so then why would anyone want to introduce a supernatural thing in order to explain the world, which we see in front of us, which they want to say is natural? So that is one way that the question is put. Another way people would put it is to say that to make a big claim requires big proof, big evidence. To make a giant claim, takes a giant amount of evidence, and so people will try to remain where they are and to continue to live the way that that they live. And we're going to talk about these suppositions today, and we're going to analyze them from an empirical perspective. And first we're going to begin by mentioning something about Judaism, which is that according to Judaism there's always going to be a natural explanation. We spoke in the previous segment about how it's required to have the range of free will. It has to be that there's always a natural explanation for the world, whether that would be that the world is totally natural with nothing supernatural, or that the world, if a person would see some sort of spirituality in the world, well, there could be other gods, was what used to be the alternative explanation that people would give. But a person has to have the ability, according to the Torah, to deny Hashem in the world. And this is, it says, I've placed before you life and death, choose life. It has to be that we have the full range of free will. So we understand that the Torah is something which says that there's always going to be a natural explanation. There's always going to be a nature. So the first thing, we should clarify is that, take a proton, right, or a neutron. So a proton or a neutron, they're made out of 3 quarks. And this is what we observe in the science. So the Torah is not coming to say that a proton is made out of fairy dust. Chas v'shalom. The Torah says, that there's a nature, and as Jews we completely agree that a quark that a proton is made out of 3 quarks, right? So in terms of one approach being better or worse empirically, in this respect, it's simply not true. I've been working as a physicist for years. I've never had any sort of conflict. Here I am at a conference in Alabama, and things are, going fairly well, Baruch Hashem. And I think people don't like what the Christians do with climate change and things like that. Or like when there was like the question about does the sun revolve around the earth or the earth revolve around the sun, and the church's response, the Catholic Church's response was very maybe you would say anti-science. So the Maharal was also around then, and he was fine with it. And Rav Shimon Pollack gives a psak on it, Evik Karkadami. And the Torahs in Judaism are not coming against science in any way. In fact, we support the empirical search for what to do. The Rambam was a doctor and at the heights of medicine. And we see that the Jews were at the height of astronomy. Some would say, and I'll speak about this maybe a little later, that the whole Jewish approach to understanding the world and to understanding Hashem is really at the basis of science. And we see that many things in science have emerged in Judeo-Christian societies. There was the golden age of Islam, in which many discoveries came about, and so I think just to begin, empirically, Judaism is something that's compatible with empiricism, if not at its root. So now we have to address these questions that I proposed at the beginning, which have been proposed to me. So the first concept. If the world is natural or supernatural, then it ought to be natural is the proposal. So first we have to understand that a person has a default, right? So if we look at a world, and it could be natural, it could be supernatural. So there's no reason necessarily to say that it is natural or that it is supernatural, right? It's like I had mentioned in a previous episode. You take a COVID test, and it's going to give you positive no matter what. This a bad COVID test. So if you have if you have COVID, it says positive. If you don't have COVID, it says positive. And so this isn't something to see the world in that it's natural. It's not supporting Judaism over not Judaism, right? This is the natural world that we see. And a person has a natural default, depending on the society in which we live. If you would go to somewhere in the West, Western culture where we always have sort of an Enlightenment culture. So you ask somebody, what's your default? And they're going to say such a thing. Their default is that what you see is what you get. We see nature, and there's only nature and natural things. But it's very interesting because if you go to an Arab country, if you've seen interviews with Arabs in different countries who are of the Muslim faith, so they'll speak to them, and they'll say something about atheism or something, and there they'll say, "Are you crazy? You think that the world came from that you think that there's no God? Are you crazy? Right? Like this is to bring such a claim, to bring such a tremendous claim requires a tremendous amount of proof, is what they would say. So essentially, we're influenced to such a degree by our society that our default, meaning what naturally resonates as true, and what resonates naturally with us is something that's very much dependent on the society around us. I uploaded the reference from last episode, which it discusses the sorts of mechanisms through which a person really not only takes on the cultural artifacts of the people around him, but a person also, their mind is affected, right? A person immersed in a majority society, even if the person spends almost all of his time in the minority society, nonetheless, these are effects that are documented by sociologists, and a person is strongly affected by the majority culture around him, and that is what resonates as natural truth to a person. So now we're going to talk about Occam's razor. So there's a concept that the simplest answer is the best answer, or the most rational answer, right? So if a person is going to say, this chair was designed by a person, right? Or this person's going to say, this chair just appeared in the middle of nowhere, it just appeared. So there's no reason to think that, the chair appeared just randomly, or even better, suppose they say that, there was a ball that bounced off of a wall, which bounced off of a door, and then it landed on the ground, and that caused a chair to form there, right? So those are things that are very complicated explanations, when the very simple explanation is that someone made a chair, right? So we have to address this concept of Occam's razor. So first, we have to understand in which context Occam's razor applies. In general, when we're talking about Occam's razor, we're talking about an explanation which is very simple and an explanation which is very complex. And sometimes it works. In terms of like human interactions in general. There's different regimes in which you could test it, and it would presumably have some validity. And then there's other regimes in which it wouldn't have validity. In fact, the universe in general does not conform to our desire for simplicity. There's many times throughout physics, we had a nice plum pudding model, and all of a sudden we don't even have like an electron. We have an electron cloud. Like that doesn't help us, right? The standard model is very nice, the standard model of particle physics, and it allows us to make some very good predictions. But we found that in certain ways the standard model is wrong. We can't explain CP violation. I'll speak later, I hope, about the how it parallels a particular concept in Torah, which is a many-layered. I'll tell you, I like to only bring examples which are many-layered when I talk about the parallel between Torah and science. I think a person has to be very careful, not to put something forth as fact, right? When there's a certain a certain overlap, it can be compelling. It could help a person to understand about the Torah. You could say Hashem looked into the Torah and created the world. A person can take Musar from it, but I think I'm not someone who's going to come on these podcasts and going to say this is the fact that this got projected from the Torah into the world, and for sure this is how it is. I think no, it's something that's compelling, and you can learn something from it. In fact, if the science turns out to be false, right? If we discover if I told you something about the standard model of particle physics and how it parallels the Machane, I think it's actually a many-layered comparison, and it's something that has a very, 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 very low probability of seeing anything like it. It's a very complex structure and different. We can speak. But if they come up and they find that there's another particle, what are you going to do, right? You have to go at these things in a reasonable way. So it can be very compelling, and I think that science in general is tremendously compelling. When we see the parallels between Torah and science, between Kabbalah, the essence of the world, the innermost element of the world, and science, the innermost element of the physical world. But you just have to be smart about the way you do it. And so basically, Occam's razor is a concept that it tells us something in general. We can see it in certain aspects of the world, but as far as the universe, Occam's razor is not necessarily going to be valid. As mentioned, the world constantly, the science constantly breaks our expectation of simplicity. But however, there's a well-known concept of, it's well-known in biology, we see it in physics. So where you see a pattern somewhere, it's very common that you're going to find that pattern elsewhere. There's like 7 examples in biology. You see it in physics as well. In fact, you can have condensed matter systems, like systems that due to their many particles which have relationships with each other produce things that are actually very symbolic and representative and comparable to things that happen at a fundamental particle level. Meaning you have some sort of effect or some sort of particle at a very tiny submicroscopic level, and you get a certain behavior, and then suddenly if you have a bunch of those atoms together, it might not do much, but you have a lot of those atoms together, a whole collective system where each molecule is affecting the other. So all of a sudden emerges these emergent phenomena in condensed matter, which are comparable to what happens at the molecular level, to the point where there's a physicist at Stanford who wants to explain particle physics as like a condensed matter thing, meaning like that what we see are particles aren't really particles, they're really condensed matter systems, and they cause these particle-like things to emerge. So it's very interesting. We see this throughout science, that patterns tend to be reflected. So now we're going to consider what are the patterns of the universe. And right before we do that, I'm just going to mention, people might want to say that God is extra, right? They might want to say we have the world we have. There's nothing else we need to explain the world. It turns out that that's not true. If it was 100, 150 years ago, people would have said it's true, even 50 years ago. And so you have to be careful, The thing that we found out in the last years is that there are 26 fundamental parameters of the universe. Things like the speed of light. 26 fundamental parameters which have a particular value, and if you would just slightly change the value of any one of these parameters, so the world not only is consciousness and life and anything not feasible at all of a sudden matter's not even stable. You couldn't get an atom. You couldn't get a proton. It's this fascinating thing that we find that you call it the signature of Hashem. The 26 the 26 fundamental constants of the universe. So they're all just right. They're all just right. And I'll tell you, they're so just right that if you wanted to have a bunch of universes and to say, to say that you have a bunch of universes and we just landed in the one that's the right one, and they all kind of have different properties, different constants. So you know how many universes you would need? 10 to the 10 to the 17. I don't know if you know how large that number is. 10 to the 10 to the 17. So they say the number of particles in our universe, our entire universe, is like 10 to the 80 is what they say roughly as their current predictions. Right? These are extrapolations. We don't actually measure these things, but you do the best you can. Sometimes you try to extrapolate, and that's what they say. So. 10 to the 10 to the 17, that's like infinity. It's exponentially larger than the number of even particles in the universe. So basically the constants of the universe are so finely tuned that scientists find themselves in a bit of a quandary, right? So why should it be? We don't know of any physical reason that the constants of the universe should be tuned as they are. And so, the Jews, we understand that there's Hashem. Hashem set the world up in the way that it should work, right? Very simple. That's unity, right? That's there's Hashem there, and He sets the properties the way. But the answer that physicists are forced to give is the concept of a multiverse. And so they say there's billions and billions and billions of universes, 10 to the 10 to the 17 universes, just like our universe, except different properties, bizarre properties, to the point that matter can't really exist in such universes. So the interesting thing is, have we ever observed these multiverses, right? And in fact, it's not only that it's empirically neutral. We haven't seen them, so it's empirically neutral. No, so we actually have mechanisms through which we theoretically could measure such universes. There's all kinds of experiments going on in particle physics, the Large Hadron Collider. I remember people that I knew they were looking at trying to find, did energy escape? Because if it escaped, maybe it entered another universe. So 50 years, probably people have been looking at these things. Nobody's found it, right? So it's something that theoretically should be empirically, feasible. You could search for it with an experiment, and we haven't found it. So that means that's empirically negative. This is a negative on the empirical scale. Whereas, Hashem, something that's beyond physicality. So when you do a physical experiment, you're not going to see anything, right? So Hashem, in this sense, it would be empirically neutral. So as far as empirically speaking, the multiverse is absurd relative to just explaining it as Hashem. And so now we're going to take this concept that I had mentioned about how patterns tend to repeat themselves in the universe. And if you recall, I recently gave some example of this. And we're going to say, what does the universe say? As you go back to the beginning of the universe, do you expect to see unity or do you expect to see multiplicity? So it happens to be that for many generations, everybody assumed that the world was as it had always been. This was the idea of the Greek philosophers, and interestingly, various Greek philosophers also had proposed that there were other universes, in fact, infinite universes. So it's interesting. You see now, how the Jewish-Greek discussions and disagreements continue to form the basis of the current society that we're in this fourth and final golus, which has the intellectual underpinnings of the Greek golus, and here we approach Hanukkah, the time this is being recorded, and we often see these same disagreements manifest for the last 2,000 years. I think that's pretty significant, and it happens to be these are also the two ideologies that have most impacted the world. In fact, the Jews are a very small people, and intellectually, ideologically, the impact that we've had is tremendous. So now we're going to look at what happens when you go back to the beginning of the world. So one, all of the volume in the whole universe, you travel back, you project back based on our current science, and you see that all of the volume converges to a single point, just like the Ramban said, 800 years ago. that the entire universe, all the volume in the universe converges to a single point. So in terms of the volume of the universe, so that when you go back you see unity, not in multiplicity. And secondly, when you look at the entropy of the universe, that is it corresponds to the number of possible states that anything can exist in. So when you go back to the beginning of the universe, so you see what was the entropy. Entropy decreases as you go back in time, and you find there's one state, right? The whole universe exists. There's only one possible state in which the whole universe can exist. Meaning, a molecule. There's different states that it can exist in. And the original universe, existed only in one state. So what about the forces in the universe? There are four fundamental forces.